So good day to all of you. Today we will describe the session 12 in the natural language processing, that is about the N-gram model. So what is basically a N-gram model? So we will go for the introduction of the N-gram model. So an N-gram model in NLP is a probabilistic language model that predicts the probability of a word or sequence of words occurring in a text. So given the previous n minus one words. In other words, it is a statistical model that learns the pattern of word usage in a language and uses this knowledge to predict the next word in a sequence. N-gram models are typically trained on a large corpus of text such as a collection of books, articles or codes. So the model learns the frequency of occurrences of different n-gram in the corpus and uses this information to estimate the probability of each n-gram. So we'll go for one example of the modeling of n-gram model. Consider an example of the statement of modeling: I love reading history books and watching documentaries. In 1 gram or in unigram, there is one word sequence. As for the above statement, in 1 gram it can be it will be separated: I love history books and watching and documentary. It will separate in single words. In 2 gram models, 2 words it will be collected, that is called as bigram model also. So I love is one word, that is love reading or history books, that is the bigram. In 3 gram or trigram model, there are 3 word sequence likewise. So I love reading one word and history books, it will take 3 words, or watching documentaries. So illustration of the n-gram modeling, that is n equal to 1, 2, 3 and so on. So we will go for another example. This is a sentence. If n equal to 1 in the unigram, it will take 1 words. This one sentence, that word is another word, another word, and sentence is so another word. This is in the unigram model. So you will go for the bigram, it will take 2 words, that is n equal to 2. This is a sentence in the bigram model. In n equal to 3, that is the trigram model. This is a sentence, it can take 3 words, that is this is a and is a sentence. Likewise it will be calculated. The examples of estimating bigram probabilities. So P, that is the probability of the subject is there, I want English food. So here probability of I of that subject, P probability of want over I, then probability of English over want, then probability of food over English. So the probability of the subject over food. So the probability it will be 0.000031. So I want English food. So evaluation, how good is our model? So does our language model prefers good sentence to bad ones? So for that, assign higher probability to real or frequently observed sentence than ungrammatical or rarely observed sentence. Then also we train parameter to our model on a training set also. So that in that way we can measure how our model is, how much good, and we can test the model performance on data we have not seen. A test set is an unseen data set that is different from our training set, totally unused. An evaluation metric tells us how well our model does on the test set. The intrinsic evaluation of the n-gram model. So best evaluation for comparing model A and B, you will take, put each model in a task: spelling corrector, speech recognizer and empty systems. So run the task, get an accuracy for A and for B also. So how many misspelled words correctly properly, and we have to also know the how many words translated correctly. So we have to also compare the accuracy for A and B. So what are the difficulty of extrinsic evaluation of the n-gram model? So it may be time consuming and it can take days or week also. Sometimes use intrinsic evaluation, that is perplexity. For bad approximation, it can be used, and unless the test data looks just like training data. So generally only useful in pilot experiments, but it is helpful to think about. So what is the intuition of a perplexity? In a Shannon game, we will know how well we can predict the next word. So words are there, 3 words are there. I always order pizza with Chinese, and these are the options: mushroom 0.1, pepperoni 0.1, archer chip 0.1, fried rice 0.001, and 1 E minus 00. The third president of the US was, what will be the predict the next word. So this is a Shannon game. So I saw dash, so what will be the next word. So this is the institution of the probability. Unigrams are terrible at this game. Okay. So but a better model of text is one which assigns a higher probability to the word that actually occurs. The Shannon game institution of the perplexity. So Josh Goldman, imagine a call, routine phone call gets 120k calls and has to recognize the operator. Let's say this occur 1 in 4 calls, sales 1 in 4, and technical support 1 in 4. So 30,000 different names, each name occurring one time in 120k calls. So what will be the perplexity here? So it can be calculated. So perplexity will be 1 by 4th into 1 by 4th into 1 by 4th. That is optimally it will be the perplexity it will become 52.6. The probability as branching factor. Let's suppose a sentence consisting of random digits. What are the probability of this sentence according to the model that assign p equal to 1 by 10 each digit. Okay, so the probability of each word is probability of w1, w2, wn to the power minus 1 by 1 we can take the formula, and it will be calculated as 10. So lower perplexity equal to better model. So training 38 million words, test 1.5 million words in WSJ. So n-gram probability it will be unigram 962, bigram we can take it will be 170, and trigram it will be 109. So in the summary we can expect that n-gram models are type of probabilistic language, and they predict the next word in sequence based on the previous n minus words, and they are trained on the corpus of the text. They are simple and easy to implement also. They can be effective for a variety of NLP tasks, and they are relatively efficient to compute. So they can be also overfitting. Some of the self-assessment questions also there. So what is an n-gram model? So basically the n-gram model, it is a type of probabilistic language that predict the next word in a sequence based on the previous n minus words, n minus 1 words. Second question, what is the most important factor to consider when choosing an n-gram order? So the options are like the size of the training corpus, the complexity of the NLP task, the trade-off between accuracy and efficiency. So here all of the above options are there for choosing a n-gram order. And some of the terminal questions are there describing the n-gram model which is trained, list out various types of n-gram model, analyze the n-gram model, language model, work, and summarize the concept, ethical implication using n-gram models. Some of the reference books are also there, and some of the web links are also there. We can go for the n-gram models. Thank you.